Hello, Matthews, Gatos here. In this lesson, we're going to look at independent and dependent events, or A intersect B. So hopefully you remember that A intersect B means and. So lesson 3 was or probabilities. This is all about and probabilities. So let's look at investigating independent events. So we have one card is drawn from a deck of cards and is replaced, or another way of saying that is with replacement. A second card is then drawn. So event A is the first card is a heart. Event B is the second card is a heart. I want to determine the probability of A. So in the deck of cards, there are 13 hearts. So the probability of picking a card and it being heart, 52 cards in the deck, 13 of them are hearts. So the probability of picking a card and it being a heart, 13 out of 52, which I can put into my calculator in lowest terms, is a quarter. Okay, next part, we want to determine the probability of event B. And event B is that the second card is a heart. Well, since the first card is replaced, the probability of picking a card the second time, being a heart, is exactly the same because the card goes back in the deck. So since the card goes back in the deck, there are still 52 cards in the deck, still 13 of them that are hearts. So the probability of event B, which is the second card being a heart, does not depend on what the first card is because it was with replacement. That is what an independent event is. Let's look at a dependent event. So one card is drawn from the standard deck of cards and it is not replaced, or we word that as without replacement, and then a second card is drawn. So in the first one, I want to determine the probability of A being that the first card is a heart. So again, I have a deck of cards, there are 13 hearts. So putting it all together, there are 13 hearts out of 52, which I put into lowest terms into my calculator, and I get that there are 1 out of 4 chance that the first card is a heart. Now, since I'm not replacing the card, I'm holding on to that first card. Now to figure out the probability that the second card is a heart is impossible to determine. And the reason is because we need to know what the first card is. Was the first card a heart? Was the first card not a heart? So because we are not replacing it, we cannot calculate the probability that that second card is a heart. This is a dependent event. Dependent events are where one depends on another event occurring. So I want to just practice this idea of classifying things as independent or dependent events. So we're rolling a die and tossing a coin. The first event is rolling a 2 on the die. The second event is tossing a coin and it landing on tails. Does me tossing a coin landing on tail depend on what I got on the die? No, it doesn't. So this is an independent event. Okay, let's look at B. The experiment is choosing 2 cards without replacement. That means I'm keeping the card, I'm holding on to it. And the first event is picking a king. The second event is that the second card is a king. So because I am not replacing the card, these are dependent events. The chance of me getting the second card being a king, it depends on what the first card was. C. The experiment is choosing 2 cards with replacement from a standard deck. The first event is that the first card is a king. The second event is that the second card is a king. Because that card goes back into the deck, these are independent events. The chance of me picking the second king does not depend on the first card because it goes back into the deck. Okay, I want you guys to omit all of page 48 because it's not part of the curriculum, so we don't need to worry about that. But I want you to add this to your notes on top. If the probability of A times the probability of B equals to the probability of them both happening, then the events are independent. If the probability of A times the probability of B is not equal to the probability of them both happening, then the events are dependent. Okay, so this is the multiplication law for dependent events. The probability of A and B happening is the probability of A happening times, now this looks like a weird notation, the probability of B/A. This just means the probability of B given that A happened. It is just a notation, and all that notation is that A happened first. So we are not going to be doing conditional probability. This is just a notation. So let's try some examples. 2 cards are drawn without replacement. As soon as I hear without replacement, those are dependent events because my second card will depend on what my first card was. So 2 cards are drawn without replacement. Determine the probability that both cards are red. Okay, so in a deck of cards, I have 26 red cards. So I'm asked to find the probability of red times the probability of red, picking 2 red cards. So I'm going to look at the first card being a red. There are 26 cards in the deck and 26 cards in the deck that are red out of a total of 52 cards in the deck. Now I am not replacing that first card. I'm holding on to it. So my denominator has to reduce by 1 since I'm keeping that first card. So since I keep the first card, there are not 52 cards in the deck anymore. There are 51. And then I want to know the chance of the next one being red. And there are 25 cards in the deck at that point that are red. So in terms of the notation, the second one here is the probability of a red given that a red happened. In other words, the probability of picking a red given that I just picked a red. So multiplying those two together in lowest terms, I get 25 out of 102. Next question says, what is the probability that neither card is a club? So in other words, not club and not club. So looking at the deck of clubs or cards, if I take out all of the clubs, there are 39 not clubs. So putting this together, I want to pick a not club, 39 out of 52. I'm keeping the card, I'm not putting it back, 51 left. 38 of those are not clubs. And again, just in terms of notation, that second fraction is the probability of picking a club given that the first one was a club. Put that into my calculator, and in lowest terms, I get 19 out of 34. So again, that notation is just that, a notation. We're not doing conditional probability. It's just the probability of picking a club given that the first one was a club. Okay, probability the first card is a king and the second card is a 5. So looking at my deck, I have 4 cards that are kings and 4 cards that are 5. So the probability of a king and then a 5. There are 52 cards in the deck, 4 of them are kings. I keep that first card, so I now have 51 cards in the deck, 4 of which are the number 5. So looking at that, again, this is just a notation. This is the probability of getting a 5 given that I got a king first. Put those into the calculator, and in lowest terms, my answer is 4 out of 663. Okay, the next question says, one of the cards is a king, the other is a 5. Doesn't specify the order. So there's a couple of ways that this can happen. We have cases here. We could get a king and then a 5, or we could get a 5 and then a king. 2 different ways of this happening. Remember again, or in math means add. I'm adding these cases together. So let's look at getting a king and then a 5. I've already done that over there, so I'll just copy that out. Now let's look at getting the 5 first. So there are 4 5s in the deck out of 52. I keep the card, and what's left is 4 out of 52 are the 5s. So same probability, just in reverse order. 5 and then king, and then here, sorry, king and then 5 and then king. 2 different cases, so I can just add those together, and the calculator puts it in lowest terms. The answer is 8 out of 663. Okay, so the multiplication law for independent events. If 2 events are independent, then the probability of A and B happening is just the probability of A times the probability of B. So this time we're going to do with replacement, which means it's independent because the card goes back. So we're going to do the same idea. So the probability that both cards are red. So there are 26 red cards in the deck. So I'm looking at 26 out of 52 for my first pick. Now I'm keeping the card. So on my next pick, I also have 26 out of 52. So I multiply those together. The denominator stays the same since the card goes back in the deck. Put that into my calculator, and in lowest terms, my probability is a quarter. Now let's do that same idea before. The first card is a king, second card is a 5. So just like before, except we're putting the card back. So there are 4 out of 52 cards in the deck that are king. I keep my card, so my denominator stays the same. And 4 out of those 52 are the number 5. So I can put that into my calculator, and in lowest terms, I get 1 out of 169. And then the last part of this question, again with replacement, one card is a king, the other is a 5, not specifying order. So again, I do have those cases. So here, 4 out of 52, the card goes back. So I keep my denominator the same, also 4 out of 52. Okay, probability of a 5, 4 out of 52 are a 5. The card goes back, denominator stays the same. 4 of those are kings. Or in math means add. So putting that into my calculator and adding the numbers together, I get 2 out of 169. So just so that we keep or probabilities and probabilities separate, I have a nice little summary there for you. Lesson 3 was or probabilities. Those are mutually exclusive. So when there was no overlap, the probability of A or B was the individual probabilities added together. In the case where there is overlap, the probability of A or B, you subtract the overlap. Now in this lesson, we're dealing with and probabilities. So and probabilities, when I have A and B, if it's independent, it's just the individual probabilities multiplied together. And probability, if they are dependent, it's the probability of A times the probability of B given that A happened first. That's all that means. So if the probability of A and B is not equal to the individual probabilities multiplied together, I know they are dependent events. So let's try these ones here. So I'm telling you the event A probability is 1/3, the probability of B is 2/5, the probability of A or B is 3/5. So I want to determine whether these are mutually exclusive events. If they are mutually exclusive events, then the probability of A or B is the individual probabilities added together, because or means add. So A or B was 3/5. A was 1/3, B was 2/5. So I want to know, adding those together, if they are equal. So on my calculator, I'll do 1/3 plus 2/5, which is 11 out of 15. So is 3 out of 5 the same as 11 out of 15? It is not the same. So since it is not the same, there is overlap. Both are happening, so they are not mutually exclusive. So let's figure out what that overlap is. This here is too much, okay? Because there is overlap of both of them happening. So let's figure out how much it is too much. So I just do 11 out of 15, take away what the answer should have been, 3/5, and this here is the overlap. That's the too much part. That's the overlap of 2 out of 15. So in part B, I want to know if they are independent events or not. So I want to know if the probability of A and B is the individual probabilities of both. So this was that overlap that we just discovered. Okay, so the probability of A occurring was 1/3. The probability of B occurring was 2/5. So you can multiply those together on your own, or you can use the calculator to help you out, and that's 2 out of 15. So since those are equal, since the probability of A and B happening is equal to the probability of A times B, these are independent events. So this is how you prove it. Okay, for question number 5, I'm just changing the questions around because we don't do conditional probability. So the scenario is the same, I'm just changing the questions. So it says A and B are events where the probability of A is a half, the probability of B is a third, the probability of A and B is a quarter. So I want to first of all know, are they independent or dependent? So I'm going to look at the probability of A and B to see if it's the individual probabilities multiplied together. So is 1/4 the same as a half times a third? Put that in and I see it's a sixth, not a quarter. So since I know that these are not equal, so since that is not equal, that tells me that these events are dependent. Okay, are they mutually exclusive? In other words, can both happen? Well, if you look here, the probability of them both happening is a quarter, so both can happen. So since the probability of both happening is not zero, A and B are mutually exclusive, which means there is overlap. So I want to find the probability of A or B happening. So since there's overlap, I'm going to take the probability of A, which is a half, add it to the probability of B, which is a third, subtract the overlap of both happening, which is a quarter. And that would be the probability of A or B occurring. Okay, for number 6, let's try some probabilities involving decimals instead of fractions. So the probability Sophia will pass math this semester is 0.7. The probability she will pass English this semester is 0.9. If these events are independent, in other words, passing English doesn't impact passing math, I want to determine the following probabilities. So before I begin this question here, if I have a 0.7 chance of passing math, that means I have a 0.3, 1 minus 0.7, 0.3 chance of not passing math because these are complementary. If I have a 0.9% chance, sorry, not percent, if I have a 0.9 probability, which is a 90% chance of passing English, the probability of not passing English would be 1 minus 0.9 or 0.1, 10% chance. So I want to know the probability of her passing both. They are independent events, which means I can just multiply those together. So the probability of passing math times the probability of passing English, multiply those together, and I can see I have a 0.63 or 63% chance of passing both. Okay, probability of passing math or English. I know that there is overlap, that she can pass both because I just figured that out, 0.63 right here. So probability of passing math or English is the probability of passing math plus the probability of passing English, subtract the probability of passing both, which I just calculated. And this would be the probability of passing math or English, 0.97. Okay, next one here. I want to know the probability of passing math, but not English. In other words, math and not English. So the probability of passing math is 0.7. The probability of not passing English is 0.1. Oh, we can't take that out, my bad. Okay, so probability of not passing English is 0.1. And then I want to multiply those together. So putting those into my calculator, I get 0.07 or about 7% chance. Probability of neither math nor English. So what that really means is not math, not English. So not math, not English. So the probability of not passing math, 0.3. The probability of not passing English, 0.1. And then I want to multiply those together. And I get 0.03. Now, there was an event in here that was complementary. Remember, complementary events are where the probability of event A plus the probability of not A adds up to 1. So let's look back and find out which of the probabilities add up to 1. So the answer to A, probability of passing math and English, 0.63. The answer to B, the probability of math or English, 0.97. The answer to C, math but not English, 0.07. Oh, that's like James Bond, 007. And the probability of math, not math or English, 0.03. which one of those adds up to 1? That will give us our complementary events. So if you look at B and D are complementary because they add up to 1. Complementary events. Passing math or English? Not passing math, not passing English. Those are complementary events. That makes sense. Okay, last one here, number 7, and then just changing this around a little bit. We're only doing A and B. We're omitting C, D, and E. So a number is selected from the first 10 natural numbers. Consider event M, a prime number is chosen, and event N, an odd number is chosen. I want to list the sample space for each of these outcomes and use it to find the probabilities. So event M is that I have a prime number. So looking at these numbers here, I have 2, 3, 5, and 7 are prime. Remember, 1 is a neutral number. It's neither prime nor composite. Okay, set N, those are all of the odd numbers. So that's going to be numbers 1, 3, 5, 7, and 9. M and N is the overlap. So you can see here they have an overlap of 3, they have an overlap of 5, and an overlap of 7. M or N is all the ones in M or all the ones in N. So I'm going to take all of the ones in N or all the ones in N or both. So I'm missing from N, I'm missing the number 1. So 1, 3, 5, 7, and then I'm missing the number 9. So that would be the ones in M or N. So now I can just list out all the different probabilities. So the probability of being in event M, the probability of event M happening is 4 out of 10, which in lowest terms is 2/5. The probability of event N, if I add those up, there are 5 of them, in lowest terms is 1/2. Probability of M or N, there are 6 there, and in lowest terms that is 3/5. And the probability of M and N is 3 out of 10, which is in lowest terms. Okay, so to summarize, if A doesn't affect B, then A and B are independent, and you can multiply the individual probabilities together. If A affects B, then A and B are dependent, which means the probabilities aren't multiplied together. It's the probability of A times the probability of B if A happened first. So is it true? Is the probability that you just read that shirt 1? I think it is. You guys can go ahead and do practice questions 1 to 14. Please omit 4, 5, 11, and 12 as they are not part of the curriculum. And that is the end of lesson number 4. You're good to go for the quiz now.